CAT interviews at Uber, Confluent, Indeed, and many more companies. I've seen it all. After countless hours on the other side of the table, I know exactly what top companies are looking for, especially in LLD. In this course, I'll share the insider blueprints, what to focus on, especially key design patterns, how much multithreading, very important, counter question, traps, and how to tackle them confidently. This course is structured, practical, and tailored on what companies are looking for right now. Let's get you interview ready right now. Now, after discussing one of the few important problems, we are now moving ahead with PubSub, like Kafka. Now, before that, I expect that you must have seen multi-threading course, because in that primarily design bounded blocking queue kind of very closely links to what we're going to do here. Obviously, this is much more advanced version of this one, but obviously I'm expecting that you know basics of multi-threading and stuff. Secondly, here you will see that we discussed basic repository pattern, service pattern, and basic Spring Boot kind of design which we usually see in LLD, along with basics of multithreading. Here we saw generics and much more advanced version of multithreading. In this, we're gonna see similar kind of scenario, but obviously linking up with a high level concept, which is called as PubSub. Now, one quick disclaimer: I will use PubSub and message queue interchangeably. Are they same? No, they are not. PubSub, for example, we have Kafka. Let's say message queue, we have RabbitMQ. Now, although there's a slight distinction between it, for RabbitMQ, message queues are basically for point to point. For example, producer will send messages to a queue, that's a single queue, and each message is consumed by exactly one consumer. So it's kind of ideal for if you want to just do the distribution of work and do the corresponding load balancing. Not primarily that much like for very high throughput and stuff. You want to if you want to do much more parallelization, high throughput and stuff, obviously then you have a PubSub. Again, both of them have their own pros and cons. I'll not discuss here. I'll keep it that for HLD, high level design video, which we have. Now here, PubSub simply says that producer will publish messages to a topic and every subscriber will consume the topic. Although don't worry about it, we'll go into very deep of this, but it is ideal for broadcasting events to multiple subscribers. Now, before we go on, I hope so you guys know the actual drill which we have. The drill says that firstly I'll discuss the actual basics of primarily Kafka. Then I'll go on to a simple scenario where you will be starting off and doing a discussion with your interviewer, which is primarily into setting. And then we discuss primarily how you'll go about what you can discuss and all that stuff. Then we'll go on to implementation, design challenges, design patterns, class diagrams, and then the actual implementation. Again, if you have landed onto this video and if you have any doubts whatsoever, please make sure that you follow videos from starting. Else, obviously, in this video, all doubts will not be solved. But if you watch the course, all of your doubts will be solved. Coming on, that after that, we'll just see how specifically multi-threading we can actually implement here. Now, why multi-threading, all that stuff? Because primarily you will see it's a multi-threading question. Now, with all that, let's start off with understanding what exactly is your PubSub model. Basically, it is for asynchronous communication. What does that mean? It means that we have multiple producers, or you can say publishers. I will use this word interchangeably, producers and publishers. So they will put some data somewhere. Forget about it where. But then there will be some subscribers, right? Or some consumers. Again, subscribers and consumers, I'll use this word also interchangeably. They will simply consume it. Now, with all that said, so that both can actually do or work asynchronously, that's where this PubSub model comes up. That one way could have been I directly end up communicating them, which obviously will restrict the bandwidth, throughput, and multiple things. Why? Because I could only be able to produce at a specific rate at which my consumer can consume it. And that can actually end up being a lot of overhead along with a lot of duplication as well. So what we do is we put data somewhere in between, and from there, that between thing, consumers or subscribers can start consuming it asynchronously. And that's what your PubSub is. So basically we'll have multiple topics. Again, what are topics? We will discuss everything, but obviously we'll have multiple topics. Then we will have efficient message publishing and message delivery and parallel execution and also high throughput. Now, what all did I mention here? Don't worry. Let's start off with the basic concept. First concept is a topic. So you will see that these are topics. right? Now, topic, basically a logical distinction is it is a topic. For example, let's say if you want your English scores can go to a English topic. Your math score can go to a math topic, and so on and so forth. So basically, imagine that it's a logical bucket which you will have, right? Let's say order data will come up, order topic. Access log data will come in, access topic. User behavior data will come in, user behavior topic. Can I put data in some other? No. So order data will only come up in order topic. It will not go in any another topic. That's the beauty of a topic, because it's a logical category. It's basically a category of data. That same category data lies in the same topic. And my publishers will simply publish data to any of the topic. And same way, my subscribers will consume that specific data. Now, it is very possible that two publishers are publishing data to a same topic. It's completely fine. Why? I can have English, pre-final score and English, let's say, final score. I want them to be, in the English topic. Or let's say I have order pre-final score and let's say order final score. I can have it in the same topic. It's completely fine. Same way, I can have multiple subscribers which will consume data, and also one subscriber can consume from multiple topic as well. It's completely allowed. Now, what happens is, like, topic will actually act as a logical channel. A logical or a behavioral distribution of data will actually happen in a topic. Now, what is a partition? Now, basically, that if there are multiple people, imagine the same thing. If there are multiple people and all of them wants to insert data into your topic, order topic. Now, because there are multiple people, it can actually become a bottleneck in terms of, scalability. So what we do is that, okay, we know the topic is a logical grouping of data. So we will individually break it down to multiple similar things, and that we call as partitions, right? That we call as partitions. Now, with these partitions which we have, what will happen? Okay, we'll have this partition P1, P2, P3, and so on and so forth. So basically what it does is it allows us horizontal scaling. What it was trying to say is that I will have this horizontal, I can scale horizontally my topic, and then I can literally have many, again, obviously if it's a bottleneck for me, I can scale that horizontally, and I can keep multiple partitions so that not necessarily every consumer has or every producer has to produce in the same partition. They can produce in different partitions. It's completely allowed. Obviously, will there be a ordering mismatch? Yes, there can be. But the fact is that inside, obviously, this is a topic. Now, inside topic, we have partitions. And a partition will keep same kind of data. But it's just that, okay, let's say if I have records, let's say 1, 2, 3, 4. Then obviously, if I'm giving two partitions, so it can happen that record 1 goes here, record 2 and 3 goes here, record 4 goes here. It's completely fine. It's completely possible. And that's when, let's say, if someone consumes that, let's say there's only one subscriber which is consuming it, then obviously it can happen that I consume 2, 3 first, and then 1 first, and then 4 first, because obviously they are distributed. But ordering inside a partition will be there, but across the partitions, not necessary. Although these are kind of high level concepts which I'm telling for Kafka, is that required? Not really. We will keep it very simple. We will keep, although in actual design, which we will discuss for PubSub, as you can see the code as well in GitHub we will discuss it very simple, which is very similar to your bounded blocking queue. But still, I just want to touch base on a few ideas which you should be knowing if you have any issues or any doubts. Secondly, we mentioned that just to achieve parallelism, we need to have these topic behavior. So sorry, this partition behavior, because partition allows us doing the horizontal scaling, and basically each partition is ordered immutable sequence. It is not like a database that you can erase some entry. No, if something has gone to partition, it is gone. If you want to overwrite that entry, you have to push another entry saying the new value is this. That's kind of what immutability means here. And as we mentioned, that it is ordered. Inside a partition, things are ordered. It will not change. But obviously, across partitions, it can change considering the initial order. Now, message within a partition will be assigned a specific ID called as offset. We will see what the offset is just now. But yeah, every message because we want to know that how much we have consumed, and that's the reason we need to have an offset. And because to also support fault tolerance and availability, we have partitions split it across multiple brokers. Now, what are brokers? Imagine brokers as servers. So that again, if you will only keep it at one place in one server, obviously, if the server goes down, your entire topic or in all the partition goes down. So as to enable fault tolerance, you make different servers and then you keep the copy of your partition such that you can achieve fault tolerance and higher availability as well. So again, although will we use that in the code? Not really. Will we use partition in the code? Not really. We will keep our code very simple. We will use simple producers, simple consumers, simple topic. That's it. We will not use consumer group. We will not use brokers. We will not use partitions. We will not use any of these things because obviously we could have used it, but it will unnecessarily complicate for you. Now, offset, as we discussed, is basically telling that what is where is producer, where is consumer. Although there is a benefit of putting up both producer and consumer, but in theory, producer will only able to produce at the end wherever it has produced, or wherever is the next empty entry. My producer can only produce there, while my consumer has a liberty that he can consume from any point. Here in this case, my consumer will consume after offset 3. So consumer knows that he has to consume after D, which means from D onwards he start consuming. Now why it is important is because although all producers, if they are pushing data to a specific, again right now let's keep a partition, although right now let's keep a partition, oh sorry, right now let's keep a topic and forget even if we have a partition or not. Imagine there's a topic with a single partition, that's it. This is, let's keep the ideology for now that there's a topic with single partition, that's it, which means there is no logic of partition altogether, forget it for now. So what I'm trying to say here is that all producers will simply push data whatever the recent place is or whatever the open place is. But if they are different consumers, right? If they're different consumers, let's say C1, C2, and C3, they can consume from anywhere. C1, let's say if they want, they can consume starting from here. C2, if they want, they can consume starting from here. C3, if they want, they can consume starting from here. It is completely possible. And also there's a functionality called as reset, which means I can reset the offset. So imagine this consumer was consuming from here onwards. But I can reset that and I can start and let him consume from the starting. So this gives us the liberty to start consuming records if I want to do some reconsumption or maybe retries, or I just want to do any business logic on top of it. So basically offsets is basically a unique identifier. As you can see, offset 7, 3 and so on and so forth. And it's always sequential because it's simply nothing but the numbers. It will keep track of the position which you have, and it will literally allow your consumers to know at up till which position I have consumed, and this is I have to start processing next. Now, because of offsets only, there are few logical algorithms and stuff which we can use to actually achieve at least once, at most once, and exactly once delivery. What is that? What it means? All that stuff we will discuss in HLD. Now, coming on, that we already know about producers and consumers. So we will have some producers, we will have some consumers. Consumer will consume from topics, producers will produce to topics. Now, keeping things simple, I mentioned that one topic, imagine one partition, so data will go inside the topic. We are assuming that data goes inside topic, although it goes inside a partition. Now, obviously, we can have multiple producers, which we have, and we can also have multiple consumers. And the best part is consumer will read the data parallelly. Why this parallelly is very strongly focused on is because the entire program right now, which I'm going to show you, is based on that how are you reading or how are you running your consumers parallelly. That's the thing. Now, before we go on, there's a term called as consumer group. Are we using this in the code? Not really. But still, I'm just telling you, consumer group is a group of consumers which can consume data from a specific topic. Now, the best part about consumer group is that if a consumer group is there, I can, if let's say I would have had, let's say these, I would have had, let's say two partitions, and let's say I would have had only one specific consumer. Obviously, it has to consume both of them. If I want to scale, I can simply add one more consumer in the consumer group, and thus I can parallelize it. Considering I always have to maintain ordering within, when I consume from a partition. So even if I make one more consumer, it cannot read from any of the other topics, because one consumer from a consumer group can only read from one topic. Although all these words, all these statements can become confusing, especially for this problem, but I just want to touch base upon, not necessarily you should need to understand it. It's good if you understand it right now. If not, no worries, we'll discuss in HLD properly. Now, we saw that, okay, here this consumer from the consumer group is empty. Why? Because obviously there is no partition which I can actually consume to. Same way here, we have 4 partitions, but I have 3. I have 3 consumers. It is completely fine that 2 partitions are being read from one consumer. It's completely fine, possible. Now, as we proceed ahead, basically, as we mentioned, that it helps us to achieve horizontal scaling for the messages which are being consumed. I can consume it much faster. I don't have to, be a bottleneck. If let's say I don't have that many consumers, I can scale my consumers in my consumer group. And obviously, every consumer will have to keep track of their latest offset, which they have processed for each partition. Now, again, as I mentioned, that we will ignore partition in the code and we will only keep a topic, so that it's much more easier for you to understand and remember. Now, lastly, the difference between producer and consumer offset is called as consumer lag. It indicates that how many messages we are still behind. So every consumer will have a consumer lag, saying that how many messages it has to still process. Although again, this is one thing which we will not use in the code, but still, I just want to know you. Lastly, basically, either you can push messages to your consumers or subscribers can pull them according to their own will. Usually, you will see that primarily you will always try to pull messages because you want to consume at your own rate, and you don't want anyone to keep on just hammering it down to you. It's kind of just not good. So you will simply end up doing that consumption by pulling things from your topic, or you can say partition to be more precise. So that's your push and pull model. Now, some of the design consideration which you need to do is that you will obviously have multiple topic support, because you can have multiple topics, right? You will have publisher which will publish data, you will have subscriber which will subscribe data or consume data, and you have to make sure that your data can be consumed by multiple subscribers. Again, you can push all data to your subscribers, but ideally you can just notify them and they can pull from you. That's completely fine. Now the biggest part is parallel consumption. Now, whenever I mean consumption, I mean both things, consumption and processing. What I mean by that is, from a specific topic, if there is a data being read by consumer 1 and another consumer 2. So what happens in this case is that we as a user should, because again, obviously consumer 1 is reading data from a topic from its own offset. Consumer 2 is reading data from the topic from its own offset. So technically these two consumers are independent of each other. If they are independent of each other, so ideally when they're consuming, they should also consume things parallelly, or I should say concurrently. So what I want is that both the consumers consuming, again, even if consuming from the same topic, should ideally consume data parallelly. And that is what I'm saying as parallel consumption. Now there is one more step, which is processing. So considering you consume the data, then you will do some processing on top of it. That is a business logic more of, but obviously after consumption will come up processing part. So again, that also we will make sure that it is being handled parallelly. Although not necessarily you want to include it in this problem, but you can just mention verbally as well. Now, some of the operations which you should know that it performs is that publisher will publish. Again, obviously it has to create as well, or maybe it gets ready-made. It's completely fine. And it will simply send message to a corresponding topic. Now, your topic should store the messages, because obviously different consumers can read it according to their will. They can reset the offset and can start reading from the beginning as well. So you should maintain that messages in the memory. Secondly, your subscribers should end up receiving the messages whenever they are consumed. Again, I can just simply notify them and they can start pulling again. If they're stuck, let's say if this is empty, and when I say empty, it will not be empty per se, but let's say I have reached the offset and there is nothing else I can consume. Then if there is any production of messages, then I'll just notify my subscribers which have subscribed to myself as in my topic. I'll notify them, and then all of them can start their pulling process from me. Now, the biggest part is concurrent message processing and consumption, primarily focusing on consumption, and processing will also go hand in hand. Lastly, some of the features will be topic based message routing, because you want your different you want your different producers to route your messages based on the topics which we have defined. And obviously parallel consumption and processing, message persistence in your topic, and supporting of multiple publishers and subscribers. Now come on to the actual fun part, that how it will go about. Now the person will simply say that design a simple pub/sub model like Kafka. Now you as in can come up by saying that, okay, what I will do, I will allow my system that there will be some messages which can be published to topic. Again, I'm not keeping partitions here. Again, I'm saying, so what I will do to keep things very simple and to also incorporate multi-threading and good single responsibility and extensibility, I'll keep things simple and I'll keep only publisher, I'll keep only subscriber, I'll keep only topic. So my publishers will push data to the topic. It can push to different topics as well. My subscriber can will subscribe from a specific topic. It can subscribe to multiple topics as well, completely fine. And then whenever this insert data happens here, I'll just simply notify my subscribers to start consumption or start consumption of messages, and then start processing them as well. Now comes a part where actually you have a rough idea, and then you are just simply putting on the points, because that you will have multiple producers and consumers, because consumers or subscribers will subscribe to a topic, and basically whenever you publish any message, all subscribers which have subscribed to that specific topic, because obviously you will publish a message to a topic, should receive that in parallel. That's the biggest word, in parallel. Now obviously subscribers should be able to consume and process independently and in parallel. Now obviously you can ask some clarifying questions, that you want to support message persistence, which obviously you will, and you want any ordering guarantees. Again, if you want any ordering guarantees, all that goes and ties back to keeping partitions, which we have already ignored in our problem. And second is that, do you want to support message acknowledgement or any redraw mechanism? What if at least once delivery, at least at max, and all that stuff. So again, keeping it very simple, I just want multiple topics to be there, that my publishers can publish to those topics and my subscribers can subscribe to them. So the subscribers can subscribe to my corresponding topics. And again, the ideology is the same, that if let's say I have two topics, and let's say I have publisher 1, 2, 3, and let's say consumer 1, 2, 3. Again, this is topics, not partitions. Don't get confused by consumer group concept, right? Okay, proceeding ahead. So what I will do, I'll just simply say, okay, I can produce, let's say like this, two producers producing to a same topic, my single producer producing to a single topic. Then I can also say that, okay, from these two topic, I'm consuming it, and let's say I'm consuming like this. So this kind of pattern is completely acceptable. Here, this is the topic, these are producers, these are consumers. Cool. Again, so I showed all the possibilities in which different partitions can put data in a specific topic. Consumers, even single consumer, can consume from multiple topics, and one consumer can consume from one topic. If you don't want to consume anything, why do you even need it at the first place then? That's the question. Now, coming on that, obviously we will support parallel execution of our messages and message ordering within a topic. Although ideally it is in a partition, but if as I mentioned that in a topic, if I keep just one partition, obviously I will achieve ordering no matter what. Now, obviously, I will have basic persistence and temporary subscriber unavailability. Let's say if my subscriber goes down and come back up, so I can just simply start reading from the same offset. If I haven't increased that, again, all that atomic behavior, all that stuff If you want, you can implement it more granularly, but not that much required because obviously we'll have a lot of other tasks as well. Now, with all that in mind, what are the key components which you have? Obviously, with this diagram, what are you transferring? You are transferring a message. Onto what? Onto a topic. Via what? Via a publisher. To who will consume? Subscriber. So obviously, I will have these entities for sure. A publisher, a message. Okay, sorry. Again, like why I cannot cut this video right now because it obviously takes a lot of time then. And the biggest issue is time. Now, obviously, I have producers, I have message, I have topic, I have subscribers. Now, with all that, let's see that I will have message, I will have topic, I will have publisher, I will have subscriber, and then the fun part comes up. The fun part is that if you would have remembered one very standard stuff which we did, in movie booking system, we did one thing in this problem that we had some screen and then we had some shows or some movie happening on that screen. So movie happening at a specific time, that is called as a show. Same way, if I said that I will have multiple topics, let's say it was T1, it was T2. Now, as I mentioned that, let's take this scenario in which consumer 3 is consuming from these two topics. Now, based on what we understood that we can consume from one topic and it should not impact or affect my consumption from other topic, because my only requirement is to in order consume messages from a single topic. If it, let's say if the messages here are 1, 2, 3, here messages are 4, 5, 6. So my only task is that in the final consumption, 1, 2, 3 should come in order and 4, 5, 6 should come in order. 1, 2, 3, 4, 5, and 6. It doesn't matter if these come here as interchangeably because they are coming from different topics altogether. And that's the beauty, which indicates that I technically can run both of these parallelly or asynchronously, which means that these both pipelines can run parallelly, which means different threads can actually run it parallelly. If that's the case, then how will I make a pair, which means that C3 T1, ideally this is one pair, T2 C3, this is another pair. So technically I'm making a T1 C3 pair, I'm making a T2 C3 pair. Same way I was making a T1 C1 pair, I was making a T2 C2 pair. Now, with all that in mind, what we realized is we will have a topic subscriber. Now, obviously, you will have a topic publisher as well, but the demand generated from topic subscriber. Why? Because you will have to handle multi-threading at a topic subscriber level, which means that these two topic subscribers can literally run parallelly because they are different topic subscribers. So a T1 C3 and a T2 C3 can run parallelly. Even if I can say that T1 C1, and T1 C1, your T1 C1 and T1 C3 can also run parallelly. So all these can actually run parallelly. And that is the reason we wanted, okay, we will have a topic subscriber. That simply says that a subscriber with a specific topic. And obviously, whenever I see a subscriber with a specific topic, I need to know that up till what offset I have consumed message by a subscriber from a topic. Because there can be, as I mentioned earlier as well, there can be a topic and there can be multiple subscribers consuming it, but they will consume from their required offset, whatever they are looking for. Now, what else? We will have topic subscriber, we have topic publisher. There should be one final main person. For us, that one final main person is Kafka Controller. You can name it as Kafka Manager, Kafka Handler, anything. But yeah, for us, we'll keep it Kafka Controller. Now, this is which will happen literally end to end. So any open API, which means any user call will literally come up here and that will handle the delegation to task. Okay. With all the corresponding core entities which we could think of, although you will see that we will now make concrete publishers, concrete subscribers, we will obviously make an interface for multiple stuff. That also that all we will see. But apart from core entities, we will have some challenges. Firstly will be concurrency control, message delivery, because we want message delivery to happen simultaneously, we will have offset management because we have now a feature of resetting offset by a subscriber on a topic. Then we will have to achieve parallelism. Again, same thing. So anything regarding design patterns, we will try to use design patterns, but primarily not diving into deep. Why? Because we already have a lot of concepts regarding Kafka and stuff, and we just primarily want to focus on that how different topics, although we will keep it clean code in terms of making different classes and stuff. Do I recommend it? Not really. Which means that you will see that here I will showcase in this, I will simply showcase that my actual answer, this answer has a lot of corresponding classes, publisher, subscriber, their interfaces, their concrete classes, and so on and so forth. Will I actually, do that in any interview? Not really, because I won't have that much time. So you will see I have, topic publisher controller, topic subscriber controller, individual model classes, and then the interfaces and concrete publisher, and so on and so forth. Obviously, it's not possible. And that's what I'll also show you, that many things are not possible. And that's where we will see that how exactly we'll implement it. Now, before implementation, I'll simply show you that, how did I make the class diagram? It's very simple. Firstly, I just made simple publisher, a simple publisher and a corresponding interface. Same I'll do for producer or a publisher. Simple publisher and a simple simple publisher and the corresponding interface. It is simple subscriber and the simple interface. Rest all the core entities which we saw, I will have a topic, I will have a message, and then you remember, right? We were seeing that we will also have a corresponding topic publisher, and to control that we have a controller. Now, as I mentioned, it is very hard many times to make different classes and keep all the stuff. Although you will in ideal sense you will have many things, which means in ideal sense I will literally have a very good design the way we discussed in movie booking system. But with that, a lot of classes increase, and it's kind of hard to write code for all of them. So in good sense, what we will do is we will ignore the interfaces, or even if we want, you can write very quickly, and we'll rather focus on concrete classes. So rather, I'm going to focus on concrete class of simple publisher, simple subscriber. I would have verbally mentioned, but I would have ignored. I would have to message, I would have to focus on message and topic. I will have to keep, my main Kafka controller, but obviously I would have ignored my topic controller, and I would have, let's say, kept only topic publisher. So again, although controller will manage all the operations which needs to be done on this, but still, I don't have time. I can verbally mention I will have a controller, and that will interact with my service, and then I will have tasks which I will delegate to my actual model classes. But obviously, with the corresponding time crunch, I should rather focus on the just one class. Same way here, I should rather focus on just one class, topic publisher. Although we have a controller which will interact with the service, which will interact with the model class, and so on and so forth. But yeah, I'm just telling strategies to save time. Okay, now what else? Again, these are primary things that we'll have topic subscriber, we'll have a topic publisher, we will have actual publisher, we will have actual subscriber, and then other core entities like topic and a message. And to handle all of them, we have a controller, Kafka controller. Now, with all that in mind, let's start off with our actual implementation. Now in the code, we have, firstly, we will have interfaces, then we'll have the corresponding concrete classes. So firstly, we have iPublisher, just a simple interface for publisher, so that I can have concrete classes for my corresponding publishers. So simply saying publish to a specific topic, which means I'll give a topic ID to to this topic, publish this message. That's it. Same way, subscriber, which will say on some message, I will do something. Again, this is not consuming a message, this is processing a message. There's a bit difference there, which means this simply says on message, if I have this message, I will do this task. It is not consuming from a topic. That's a small difference. And I will tell how exactly and why exactly does it matter, all that stuff. Now, secondly, we will have a simple subscriber, which is a concrete implementation of my subscriber saying on message. which means I'll simply get a message and do something. I am simulating some processing here, but you can do something, whatever you want, totally your wish. Business logic will come up here. Same way for simple publisher, I'll do something here. When I say I'll do some publish here, but publish will publish to a specific topic. This message should go to a specific topic, which means that from this publisher, you ideally have to call something that should put data inside a topic. So one way is I can call a topic from here. Ideally, you should not do it, which means simple. Again, if you would have had a controller that could have done it, which means I can have a publisher controller which could do the job of doing that processing and ingesting of data to some topic. But here, to keep it things simple, to keep it minimal and simple, we have taken a Kafka controller, which is, if you remember, Kafka controller was the main controller for our program. We have taken the same controller, saying that, bro, this will help us insert the data onto, or I should say publish the data onto my corresponding topic. Now comes couple of other classes which we are using, one of them being message class, representing a very simple straightforward message. Then comes the most interesting one, which is the topic subscriber. As we mentioned that for us, the primary use case is that multiple subscribers should consume parallelly, which means that just to showcase that this is subscriber 1, topic 1, subscriber 2, topic 1, this pair is indicated by T1, S1. This is indicated by T1, S2, right? Now, with all that, that you will have to keep a subscriber, you will have to keep a offset. For what? For a specific topic. So topic subscriber says this subscriber is subscribed to a topic consuming from a specific offset. Now, same logic will go to publisher. It's just that the publisher don't need offset because publisher will only publish in the very end. That's it. Now, a topic should ideally have its name and its ID just to uniquely identify it. Name is, business logical grouping name, which you're thinking of. The best part is the topic should have a list of messages because topic has to store that messages into its memory. Now, whenever I should add a message or I get a message, again, if you want, you could have had, this messages. You see, it's a simple array list. I could have made it as a copy on write array list, and then I don't need to keep them synchronized. Now, the only reason I kept them is because if for a specific topic, right, there are multiple publishers, just to not run into a state of corruption, I just kept this synchronized. If you don't want, you can remove that and you can keep this specific data structure where the messages are going into, which is a simple list right now. You can keep that as copy on write array list. Now, if you don't know, then we have discussed that in a concurrent collections video, corresponding crash course. Now, the same logic goes for topic publisher. It has to publish and doing the same corresponding task. Here, it's a simple controller, right? Because again, so far we had the topic publisher, but someone has to control it. So that controller does the job. Now you will see that right now, if it's a topic publisher controller, ideally it should handle a topic publisher. And that's true. We can remove this, and we can literally keep a topic publisher as well. And this is what you will see in, topic subscriber controller. We have used the same logic. But yeah, even if we keep this, it's completely fine. Now, in topic subscriber, again, this is very, 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 very important because my primary goal is that different subscribers can operate parallelly, or to be more precise, different topic subscribers can operate parallelly, which means that if I have two subscribers and this subscriber, let's say S1, subscribe to both T1 and T2, then both S1 T1 and S1 T2 should operate parallelly. Now, with all that said, I will have a topic subscriber, which again I'll just simply have a corresponding run method because I'm just kind of implementing Runnable. Although if you want, you don't need to specifically have that Runnable, all that stuff. You can there are multiple ways to go about it. All that ways we are discussing in the past problems as well, these problems as well. Along with it, we have discussed a lot of ways in the crash course as well. Now coming on back, we will have a simple run method, which means that in my any executor service, I can make an object for it, object for this topic subscriber controller, and I can pass that object by saying, okay, new topic subscriber controller with, let's say, a specific topic subscriber as an argument, and then this will automatically ultimately call the run method whenever I will start the process, or let's say any thread which I have. Although we will use executor service to run our operations, because obviously we don't manage our things ourselves, right? We let executor manage from our behalf. Now coming on, the main logic comes up here. You want your different topic subscribers to run concurrently. So obviously what you want is that if there is some data ingested onto a topic, you should notify all the subscribers. Again, let's say if there is S2, sorry, if there is S1 and S3, right, which is subscribing to my T1. If that is the case, I know for sure that as soon as any data is ingested onto T1, I don't care who did it. I don't care about the publisher. But if there's any ingestion, please notify these people who are subscribed to me. And when I say these people, I'm not saying notify S3 completely. No, notify only T1 S3. Why? Because there could be T2 S3 as well. Why will T2 S3 be notified when you only have ingestion in T1? And that is the reason we have this bifurcation. We have this unique stuff where we are saying, okay, it should be T1 S1, it should be T2 S2, and so on and so forth. So we will only notify T1 S3, or I should say T1 S1. Why? Because only these subscribers are the one which are subscribed to a topic T1. So to do all of that stuff, I will firstly run an infinite while loop, which will keep on consuming messages. Now, Aryan, but it will use CPU resources. No, it will not. That is the beauty of locking. Why? Because you firstly will come inside this section. You will lock on the topic subscriber. Now, why it is done? It is because imagine if you had a T1 and let's say a S1. You had a simple topic, but then let's say if you have multiple threads, let's say all of them, let's say T1 S1, like all of them for T1 S1, let's say for a specific topic subscriber, there are a lot of threads which are trying to, do the task for you. But you want them to, not kind of hamper each other. You want them to be synchronized. Right? Else your data will be corrupted and you will be in a very bad state. And again, the ordering will also go haywire. So for all that, you have to synchronize on a topic subscriber. Then I will check if I have surpassed the offset I could have had, which means if I don't even have that many messages, but my offset has passed the limit, which means I have consumed all the messages. In that case, I should wait. The moment I say wait, I will release the lock. And again, if you don't know how does this work, please make sure that you are watching the crash course. Coming on back, we realize, okay, we'll simply release the lock, and then I can simply, whenever there will be any ingestion in the data, right, I am kind of releasing the lock, as in like I'll wait and I'll release the lock. So it can only be, waken up again when someone will notify it. So who will notify it? Whenever there's some production in my T1, then at the same time, I'll notify all the topic subscribers of a T1. Again, this is we will see when we will produce data, but this is what we can simply do. Although this logic of waking up people we can keep in at a separate place as well, but all that we will keep in a Kafka controller. But again, as I mentioned, that we can actually keep it more extensible if you want. Now coming on to the main logic, if for any reason, if it is not fully occupied, if it is not fully used, if I have not reached my offset to the end, I can still consume. I'll consume the message and I will say, okay, this is the message to process. Now I have got the message to process. Now I have got the message, in the perfect order. Now processing of message can happen even in separate thread or outside of a critical section. So it's the reason you came out, and then this can literally happen at a separate thread as well, or maybe separately, but there's no locking as such required because obviously this can take time. So it's very bad practice to wait unnecessarily if you can actually, only let the person wait until you get the message out and then process that message in a separate thread or out of your critical section. And that's how your simple topic subscriber will actually work. Cool. And again, it will keep on running infinitely because obviously the moment any message comes in, I'll notify all the topic subscribers, and that's how they will know, okay, I have to just start consuming. If there's anything else, because again, if they're waiting, okay, I'll just notify them. If not, then obviously they will keep on consuming with their own pace, considering with their own pace. Now let's come on to the main part, which is the Kafka controller. Now this helps us to say that all the main methods, for example, creating a topic, subscribing it, and publishing a message, and resetting the offset, and shutting down. Why shutting down? Because obviously it's you have executors, you want to shut down that. So what I will do, I will use a subscriber executor, because obviously I want to run all these topic subscribers controllers concurrently. So I will keep that subscriber executor so that I can run these corresponding tasks. Now, I don't know how many topics will subscribe to how many subscribers, and so on and so forth. So I will keep a cached thread pool. For the folks who don't know, please go and watch the video. But yeah, we'll keep the cached thread pool. Now, one thing else which you obviously would have seen so far is I will keep a topic ID to the list of topic subscribers. This says for this specific topic ID, these are all the topic subscribers. These are all the topic subscribers which I should notify them. So if there is some ingestion happening to a specific topic, all the topic subscribers for that specific topic, I'll just notify them, and notify ultimately will help me to break this condition of wait. Cool. Again, we will see that also. But yeah, these are the primary stuff which we want to know about. Now, when I say creating a topic, it will simply go and will firstly say that, bro, this is the corresponding topic ID and this is the topic which you have created. So if I go up, this is my map just to create the topics so that I know I can keep track of all the topics being created. Secondly, subscribe. It's an important thing because here you are saying a subscriber should subscribe to a topic. That's it. So what you will do, you will make a topic subscriber. You will make a topic subscriber by saying a simple new. Now with that new, you also should start running it. So I will use my subscriber executor, which is a cached thread pool, and then I will submit a task saying a new topic subscriber controller with this topic subscriber. Just pass it, and then you will have a task running on a separate thread altogether. Again, if it takes time in IO, if it takes time in processing and stuff, cached thread pool is flexible enough to handle stuff from your behalf. Now, with all that, there's one small catch that if let's say I want to have multiple threads for the same for the same controller, or I should say for the same subscriber, I can keep that, I can keep a hash map of it as well, and rather than making a new every time, I can use that same one. With that, I can I actually have multiple threads trying to do the same job, although we have done the synchronization in the code already, so it will not hamper. But yeah, it can actually improve the performance as well. But again, not required. Obviously, it will overcomplicate stuff. Now comes the publish part. Publish will simply say that I will take that topic, I get the topic out from my hash map, and then I will add this message into my topic. The moment I add it, I will make sure that all the topic subscribers should be notified. Now, again, as I mentioned, if I would have kept multiple topic subscribers for a topic subscriber pair, then I will do a notify all such that I can notify all of them. But again, notify also works perfectly fine for our case. Same way, if I want to reset the offset, I'll simply go check what is the what is corresponding I have topic subscribers for that specific topic and subscriber, because again, ultimately I'm saying reset the offset. So I'm technically targeting reset the offset from, like, by a subscriber to a topic, just reset that. So with me, I only have the topic subscribers. So from the topic ID, I'll get the topic subscriber out. Now with that, I will iterate to get the actual subscriber out from my topic subscriber, and then I will reset its offset. The moment I reset it, I should make sure that I will also notify my corresponding whatever topic subscribers was pending. I'll just simply notify that. Why it is required? Obviously, what if it would have completed the offset and if it is waiting for new task, but then I reset the offset, so even if there's no new task, but still it can start consumption again. That is the reason I will just notify it. Now lastly, shutdown will simply make sure that I'm shutting down my subscriber executor. Now this is the main code. Now the client code, as in the user code, looks like how we can interact with the system. So firstly, I will make two topics, T1 and T2. Topic 1, topic 2. I have simply made it here. Now let's change the color. Then with this topic being made, next is I will make 3 subscribers. So as you can see, I have made 3 subscribers here as well. Next, I have few subscribers subscribing to a topic. So S1 subscribing to T1, S1 to T2, S2 to T1, and S3 to T2. So S1 to T1 and T2, as you can see, S1 T1 and T2, S2 to T1, S2 to T1, and then S3 to T2. Now with all that, you can also see that I have just subscribed it. The moment I subscribed it, nothing will happen right now. Now I will simply have 2 publishers. Now when I say publishers, I'll simply make P1 and P2 as 2 publishers. Now when these are made, I will now start putting up messages. So in my topic 1, I published a message M1, topic 1 message M2, topic 2 M3. Again, I don't care who is publishing it. I just care that topic 1 has now M1 and M2 in this sequence. Topic 2 has message M3. So whoever has subscribed to T1, which is in this case S1 and S2, will get M1 and M2. So what will happen? That subscriber 1 will get M1, subscriber 2 will get M1. So why this happened? The moment the first message M1 was added into the T1, my 2 subscribers S1 and S2, again, because the moment you add it, you will notify all the T1 S1, which means you will notify all the topic subscribers of T1, which is T1 S1 and T1 S2. You will notify them and they will start consuming it. So that's what we can see, that S1 consumed M1, S2 consumed M1. Now after that, next line is publish M2 in your T1. This is gone. As I publish M2, again it will notify both of them, and with that I will get M2 being published. I'll get M2 being subscribed. Where's M2? M2 being subscribed, and let's say M2 being subscribed here as well. Now again, because of concurrency and stuff, I have just shown that okay, things can become jumbled altogether. But yeah, this is actually how it can take time while processing, while you ingesting, and so on and so forth. Same way, next we are saying okay, M3 was actually pushed up in T2. T2, S1 and S3 are there. So S1 and S3 will get the message M3. Right? This is actually what's happening. Now next we'll just have a bit sleep so that I can distinguish between these tasks and the next task which will come up, which means the next message which will come up. Next message says you have M4. So M4 comes up in T2. So M4 comes up in T2. So you will see M4 comes up in T2, and T2 is subscribed. If I go up, T2 is subscribed by S1 and S3. So S1 and S3 are there. Now next I have M5. M5 comes up in T1, and T1 is subscribed by S1 and S2. It is subscribed by S1 and S2 is M5. And lastly, when I did a reset of the offset of what? Subscriber 1 and topic 1. So subscriber 1 and topic 1 offset was reset, which means that whatever messages T1 has, which was M1, M2, and then M5, I should process them again. or consume them again. So I'll consume M1, M2, and M5 again. And that's how your actual process can work. Again, I could have had different threads pushing the data simultaneously, all that stuff. You could do it completely fine, but yeah, just to keep it simple, short, concise, explain it, because obviously it is already such complicated. I don't want to complicate even further by adding a lot of unnecessary stuff in just one video. Obviously, we'll discuss HLD, in which we'll discuss a lot in depth about Kafka. But yeah, this is primarily, it should be primarily a lot more, because again, it is entirely backed up by a simple logic of, your blocking queue. Obviously, like it's kind of advanced version where you're going one step ahead of notifying others, and so on and so forth, kind of keeping that relatable to the real life example. Now, lastly, you actually were able to achieve separation of concern. Why? Because if you look at the code, you'll realize that you firstly had, your publisher interfaces and then concrete publishers. Secondly, you have the same thing for subscribers, concrete subscribers. Then you were saying that I will use concrete publisher and subscriber controller. Although I could have had different controllers as well, but I just kept basic model classes and the final controller, which will control the main thing, which means everything. So my user, my main, will communicate with my controller to do my task done or to get my task done. Now, with that, I have good number of separation of concerns. I have good single responsibility. Although obviously I can improve on single responsibility, but it's good enough. This is much thread safe. And obviously with all that, I was able to build a robust, scalable, and a good design solution, considering your interfaces, how you're injecting them, how you're using them, and so on and so forth. Cool. I hope you guys liked it. Again, it's a bit tricky question. Although I feel like that last 4 questions are all tricky. Again, I'll say last 3. Fourth one is easy and not that tricky. But yeah, in all of these we learned something new, and that's what the primary goal here is. That in the end you are much more familiar with the basic LLD problems. So now we are focusing on a bit more higher level. Let's say focusing more on multi-threading, focusing more on generics, focusing more on Java, focusing more on the actual stuff of good design in production code base and so on and so forth. Cool. Let's hit the like target of 250 likes. See you next video. Until then, goodbye. Take care. Bye bye.